Hi there, my name is Airil, and if you happen to be my student, you can call me Teacher Airil. Airil is pronounced I as in I and Ril as in grill. Airil. To remember my name, you can think of the sentence, I really love math. A little bit about my background. From these two pictures, the one on the left being lines of codes and the one on the right being a laptop in an office. If you guess my background has something to do with computers, then you are correct. I have a bachelor's degree in computer science. I have 6 months of experience as a programming tutor where I taught kids programming, and I have 1 year of experience as a business analyst and software developer where I work between clients and programmers to build business softwares. This here is my graduation. This here is my internship, 6 months as a programming tutor, and this here during my 1 year contract as a business analyst and software developer. Now, about my interests. As you can see here, this picture, this is my desktop PC, my computer. I saved a lot of money and I ordered all the parts online and I built this computer with my own 2 hands. It is actually a hobby of mine because I love computers and I love gaming. So my favorite video game ever is Rocket League. It's basically soccer or football, and you play it using cars. So it's car soccer or car football. So you can drive around, you can boost, you can jump, you can fly, you can hit the ball, and it's really fun. My favorite video game ever. Another video game that I'm recently playing is F125. I recently got into Formula 1 and I just can't get enough of it. The game F125 is just really fun and enjoyable. I had a great time playing it, and I still am. My favorite movie ever is called Back to the Future. I think it's the most perfect film ever made. It is the best movie, just the most perfect movie ever made, and it's my favorite franchise ever. But a close second though is Star Wars. I'm a huge Star Wars fan, a huge Star Wars nerd. I love all the movies, but my favorite Star Wars movie is Revenge of the Sith, a great origin story. Now, my style of teaching is I love to explain the concept, the logic and reason behind everything we learn. I love to explain it in order to help my students understand. So my way of teaching is using logic and reasoning. So take a look at this question, for example, about patterns. So we have 3 rows and 3 columns. So we can see the pattern in the first row. For the black square, it starts from the left and it goes to the middle to the right. It does the same in the second row, only being in the middle section, it goes from left, middle, right. So we can assume in the final row it will do the same. Since all of the options show the black square on the bottom right, so we don't have much option there. All of the options seem correct for now. So let's look at the circle. The circle in the first row, it goes clockwise because it starts bottom right and then goes bottom left and then goes top left. But in the middle row, it goes anti-clockwise. As you can see, it starts bottom left, goes bottom right, and then top right. Back in the final row, it goes back to clockwise. So it goes from top left, then it goes top right. So we can only assume it will go bottom right. That leaves us with 2 options, A or C. So now let's look at the arrow. In the first row, it stays in the bottom section, but the direction it shows like this, right? But look at the position. It starts from the left, goes to the middle, and then goes to the right. In the middle row of this the squares, it stays the same. It stays in the middle. So we can ignore that because in the final row you can see it's now at the top section, and it goes from right, middle, and we can only assume it will go to the left, making our best option for our answer is C. So that is my style of teaching. I love to explain the concept, the logic, and the reason behind everything we learn in order to help my students fully understand it and remember it forever. Thank you very much. Goodbye. Hey guys, today we'll be doing an exercise on quadratic equations. So let's get started. This question is asking us how many of the following equations are always quadratic equations. Now, we have to remember the standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. We also have to remember that a cannot be equal to 0, because if it is 0, then we're left with bx plus c, which is a linear equation, therefore it is not a quadratic equation. So a cannot be 0. Okay, now let's start with our first equation. X squared minus 2x minus 1 equals 0. We see here we have our ax squared, a being 1, we have bx, b being negative 2, and c being negative 1. So everything looks good here, therefore it is a quadratic equation and always a quadratic equation. Now, our second equation, do not be fooled. Even though this is the standard form of quadratic equation, we do not know the value of a, b, and c. Being random variables, a, b, and c can represent any number. So, since this equation does not state that a is equal to 0 or not, we cannot assume that a is a non-zero. So, this cannot always be a quadratic equation. A, b, and c are unknown. If a happens to be 0, then it is not a quadratic equation, therefore making this cannot always be a quadratic equation. Okay, now let's move to the third equation. We see here we have a fraction, 1 over x squared. This can be rewritten as x to the power of negative 2. Now, in quadratic equations, we cannot have any negative exponents. You see, in the standard form, we only have to the power of 2 or to the power of 1 or to the power of 0. So if we have to the power of negative 2, therefore it cannot be a quadratic equation, making this cannot always be a quadratic equation. Now, let's move to the fourth equation. Now, this can be tricky, but this can be rewritten as negative 1x squared plus 0x plus 0 equals 0. Now, we see here a is negative 1. It's not equal to 0. And quadratic equations do not state that b and c cannot be 0. They can be 0. Only a cannot be 0. So since a is a negative 1 and we have our x squared, b and c are just equal to 0. That's why we don't see them. We don't see the bx and we don't see the c. And it's equal to 0. So it looks good. This is a bit tricky, but this is always a quadratic equation. Now, let's move to the fifth equation. We see here we have a y here, and we have two variables here. The standard form states that we only use one variable. We use x usually. We can use y if we want, but if we want to use y, we need to use only y. We cannot have two variables in quadratic equations. So if we see two variables, that makes it immediately not a quadratic equation. So this cannot always be a quadratic equation. Now let's move to the final equation. First, we need to expand this. So expanding this, we get x squared minus 3x minus x plus 3 equals x squared. Now solving this, we move x squared, either x squared to the other side, it'll cancel each other out, leaving us with a negative 4x plus 3 equals 0. Now, this here, a would be equal to 0 because we don't see an x squared here. And seeing this x and a c, this here is a linear equation and not a quadratic equation. Therefore, the final equation cannot always be a quadratic equation, making our final answer B. Only 2 equations here are always quadratic equations. Thank you very much. I hope you learned something. Bye-bye.